Okay, so let's go ahead and go over gas properties. So one property of a gas is that gases are considered to be fluids. Okay, by fluid we mean that that gas is free flowing. There's no constraints to that gas, so it's a free flowing molecule. Okay, for example, if we have an air particle, that air particle can travel in any direction. There's no constraints to it. That is a free flowing molecule. Okay, next property is gases are low. They have low densities. So if you remember density back to when we went over in the first week, density is how tightly packed atoms are. So you should have seen that particles, or rather atoms of metals, are very tightly packed. So a metal would look something like this. Things are very close together. Okay. However, this would be a metal. If we have a gas, gases they have much lower densities. So a gas, its particles would be much more separated. So compared to the molecules of a metal, gases have very low densities and they are very separated. Okay, so the particles are not close together. However, because they are separated and free flowing, it brings us to the next property, which is compression. So gases are compressible. In other words, particles can be made to move closer to each other or further away from each other. Okay, so for example, let's say I have this system here. I have the same container, but let's say I have a plunger, and I take that plunger, I move that plunger this way, and I make the volume smaller, right? So I compress the gas into a smaller space. So I have 1, 2, 3, 4, 5, 6 particles there. I'll go 1, 2, 3, 4, 5, 6 particles there. So we've made them have you can say even have a higher density. They are closer together. Okay, so that's what compression means. We are changing the spacing between those molecules. So gases can be further away or closer away depending on their volume. Okay, all right. Gases have which you should have seen in the last unit or in the last lesson. Gases have they exert a pressure. Okay, so what is pressure? Pressure is going to be a force exerted over an area. So force over a given area. Okay. For example, let's say I have a area here, right? Like just a slab of, let's say it's glass, or it can be any material really, with the sides are 1 millimeters in length. Okay, so my area would be 1 times 1, right? So it'd be 1 millimeter squared. Let's say I put a force on this here. Let's say I put a force of 1 Newton. That's how we measure forces. So you don't have to worry about that too much. Let's say we put a force of 1 Newton. Okay, so that's a force over an area. That's a force of 1 Newton over 1 area. In other words, my pressure is 1 Newton over 1 meter cubed. That's what I call 1 Pascal. Okay, so scientists use this kind of as a way to quantify different types of pressure. It's not really important that you understand where this comes from, but it's kind of giving you an idea as to what pressure is. Okay, so if we're looking at, let's say at sea level, let's say I took the same 1 by 1 piece of glass, right, and I put it at sea level. So, because remember, because pressure changes. So if I'm at a mountain, and I'm at, let's say this is the ocean here. If I'm at the ocean, this pressure is going to be different than this pressure because of gravity. And we'll go over that in a bit. But let's say I take this glass, I put it here at sea level. At sea level, so at sea level, my pressure would be 101,350 325 pascals. It's a pretty large number, right? But we don't necessarily feel that, because when you feel pressure, you're feeling pressure all around you, from the top, from the bottom, so all of that evens out and the forces cancel each other out and you don't necessarily feel that pressure. Okay, so this, we can also change these units and put it into kilopascal. So if we're doing kilopascal, we should have, from the last unit or the last lesson, we should have seen that this many pascals is equal to 1.325 kilopascals. Or we can also say 1 atmosphere, 1 ATM. At sea level, when I'm right at sea, so right at sea level, the pressure is 1 atmosphere. Or also, you can say it's about 101 kilopascals. Okay, so we won't go too much into unit conversions because there was a video that you should have seen on that already. Okay, all right. The last thing we want to go over is the kinetic molecular theory. So the kinetic means moving. The kinetic molecular movement, the kinetic molecular, write that in here, molecular theory basically states that if we have gases that are in a system, or so we say the system is just like a certain scenario situation. So we have this container here, which I'll call my system. If I have gas particles in here, the kinetic theory states that these gas particles are in constant motion, so that's one part of the theory. They are moving in random directions, okay? And they are colliding with the sides of the container. So particles are moving, constantly moving, right? They're hitting the sides of these containers. These collisions, that's where pressure comes from. So pressure is due to collisions. That's what the kinetic molecular theory is stating. Okay, so if I have more collisions, I'm going to have more pressure. So what's the relationship between temperature and pressure? Well, if I heat something up, think about it. Someone puts a lighter out under you, where you're going to probably move. You're probably going to get running, right? So same thing with particles. When particles are heated up, they tend to move faster. Say these arrows represent their movement. After I heat it up, I know it's blue, but after I heat it up, things are going to move way faster. So things are going to be moving a lot faster. So in other words, when my temperature goes up, I also have an increase in movement, an increase in kinetic energy. Okay, kinetic energy. Things are moving faster. And this will come into play later when we study those other laws. Okay, but that's all we're going to go over for now.